Hi everyone, hope you all are good. So we're going to grade 10 maths. So we're going to start with the chapter graphs of quadratic. You can find the chapter graphs of quadratic in the Nelson Principles of Maths, Nelson grade 10. Book. That is the name of the book I'm following. Got it? Principles of Math, Nelson grade 10. Sorry. Okay, so let's just start with the lesson. The lesson we're going to cover today are quadratic fact models using factored form, then explore quadratics, and then we'll do exponential graphs. So let's just start with the first lesson, that is quadratic models using factored form. Okay, here I'm on um, princip Principles Math 10 Nelson book. The lesson I'm going to start with is quadratic models in factored form. So let's just start with the lesson. Okay, a curve could fit. A curve that approximates or is close to the distribution of points in a scatter plot is known as a curve. Good fit. Quadratic relation. A process fits the second degree relation y equals ax square plus bx plus c to the data. Let's start with the practice questions. Okay, here is the practice. So let's just start with the practice questions. A parabola passes through the points. You are given with the points are negative 4, 10, negative 4, 10, negative 3, negative 2, negative 6, negative 1, negative 8, negative 6, 1, 0, and 2, 10. Determine the equation for the parabola in factored form. Express your equation in standard form. The graphing calculator and quadratic relation to verify the accuracy of the equation you determined. So let's start with question number 4. Okay. So let's start with question number 4. Okay. Let me just copy and paste the question. Mm, okay, here is the question. A parabola passes through the point 4, 10, 3, 0, 2, 6, 1, 8, 0, 6, 1, 0, and 2, 10. Determine the equation of the parabola. Okay, in factored form. Okay, let's start with the first one. We have to write down the equation in the factored form. Got it? So just look at the points given. The given points are, just look at the zeros. The zeros are at x equals 1. Here you can see, here is the 1 and 0, and here is the 3 and 0. Got it? These are the two zeros. Got it? I think it is negative 3. Wait. Yes, there you have all the negative sign here. Negative 4, 10, negative 3, negative 2, negative 6, negative 1, negative 8, 0, negative 6, 1, 0. Okay, so you have these zeros at, just look at the point, we have the zeros at x equals 1 and x equals negative 3. Got it? X equals negative 1 and x equals negative 3 and 1. So the equation is y equals a times x minus 1 and x plus 3. Got it? That is the equation in the factored form. So let's just substitute any in the equation. Let's see, the y-intercept is 0, negative 6. That is the y-intercept. X is 0 and y is negative. That is y-intercept. Got it? So let's just put y-intercept into the equation and solve for a. Got it? Y is negative 6. Negative 6 equals a, 0 minus 1 and 0 minus 3. Basically, we need to find the value of a. Got it? Okay, so it would be negative 6, a negative 1 times 3. So it would be negative 6, a times negative 3. So divide negative 3 other side. So it would be a equals 2. Got it? That means a equals 2. Now the equation in the factored form is y equals a is 2. So it would be 2 times x minus 1 and x plus 3. That is the equation in factored form. So for the b part, express your equation in standard form. Now we have to write the same equation in the standard form. Got it? So just solve this equation. It would be 2 x times this one, x times x is x square plus 3x, then minus x and minus 3. Got it? When you multiply minus, so it would be minus 3. So it would be 2 times x square, 3 minus 1 is 2x minus 3. Then let's just multiply it to 2. So it is 2x square plus 4x and minus 6. Got it? So for the third point, you have to plot the graph on the graphing calculator. Got it? Okay, let's see the next question, which is the next question we can do on the board. Okay, the next one is a water was launched for a, let's do sixth one. A water balloon was launched, no, okay, sixth. An emergency flare was shot into the air from the top of a building. The table gives the height of the flare at different times during the flight. Tall is the building. Use the data in the table to create a scatter plot. Determine an equation of for the curve you drew. Use your equation to determine the height of the flare at 2.5 seconds. Got it? So let's just start with question number 6. Okay. Mm, Okay, the first one we have to find a part is how tall is the building. We have to find the length of the building. Got it? So you are given mm, the flare was shot into the air from the top of the building. Got it? So that means that's the one that is on the time 0. Got it? So on the time 0, the height of the building is 60. That means the height of the building is 60 meter. Got it? For the A, the height of the building is 60. Since the flare was shot from the top of the building at time 0, so from the table of values, the height of the building is 60 meter. Got it? That is the one we get from the table. Okay, the B part is um, use data. Okay, you can create a graph. Got it? You can use any graphing tool. Okay, then the third one is determine an equation for the curve you drew. We have to determine the equation. Got it? You can see where is the zeros, the graph. The zeros are 0 and 60, and the y-intercept is, you are given the y-intercept 0 and 60, and the 0 is 6 and 0. Got it? So the equation would be y equals, the zeros are zeros at x equals negative 2 and x equals 6. Got it? These are the zeros of the graph. So the equation would be y equals a times x minus 6 and x plus 2. Got it? Okay. So we are given the y-intercept, that would be x is 0, y is 60. So let's just put the y-intercept in the equation. 60 equals a times 0 minus 6 and 0 plus 2. So it would be 60 equals a times negative 6 and 2. It would be 60 equals a times negative 12. So a equals negative 5. So the equation would be y equals negative 5 times x minus 6 and x minus 2. Got it? And then for the d part, you are given use your equation to determine the height of it at 2.5 second. You have to calculate the height at 2.5 second. So let's just replace all the x values with 2.5. Got it? So it is negative 5 times 2.5 minus 6, 2.5 minus 2. Got it? So it is negative 5. 2.5 minus 6 is negative 3.5, and it is plus 2, not minus. So 2.5 plus 2 is 4.5. So when you calculate the value, it would be 78.75. That means the height of the flare is 78.75 when time equals 2.5 second. Got it? Okay. This is to question number 11. Okay. Determine this square dot. Okay. Diagram 1 has just 4 and diagram 2 has, let me just count them. Okay. The dots are increasing in length. Got it? For the diagram 1, has the side length of 2 dots, and for the diagram 2 the side length is 8 dots. For diagram 3 the side length is 6 dots. Got it? So let's just calculate a pattern for this. Got it? Like here you have the side length is 2, then the side length is increased to 4, then 6. Got it? So let's just calculate any formula for the side length and then we'll question number 11. Okay, that means the side length is 2 times n. When n equals 1, it is 2 times 1, 2. When n equals 2, the side length is 2 times 2, 4. When n equals 3, the side length is 2 times 3, and that is 6. That means the formula for the side length is 2n. Got it? So the total number of dots in the pattern are, you can see it like 6 here and 6 here. So it form a square. Got it? That means the pattern is 2n whole square. Got it? That is for the side length and that is for the number of dots. So we have to calculate the number of dots in the 20th diagram. So just replace n with 20. So it is 2 times 20 and we have to calculate the square. 20 times 2 is 40. You have to have 40 square, that equals 1600. That means in 20th diagram you have 600 dots. Got it? Okay. You can complete the test by yourself. So if you need more help with any of the lesson, you can contact her on the Skype. They are available from Monday to Friday, 5 to 9. Got it? The next one is exploring quadratics and exponential graph. So let's just start with the lesson. Okay, here is the difference between the graphs of the parabola and exponential graph. The patterns in the table of values for y equals 2x can be used to determine the meanings of this is the graph of y equals x square, and this is the graph of y equals to, this is the exponential graph. Got it? Here is some points. The graph is symmetric about y-axis. The parabola, the graph of the parabola is always symmetric about y-axis. Got it? But the exponential graph is not symmetric. The graph of parabola has x-intercept of 0 and y-intercept of 0. But the exponential graph has y values increases as x values increases. Got it? Sorry, graph has no, the exponential graph has no x-intercept and intercept of 1. Got it? It just have a y-intercept, and y-intercept is 1. Got it? Okay, for the parabolic graph, the y values decreases and then increases as the y values decrease and then increase as x increases. Got it? But for the exponential graph, and this is in the positive direction, the y value increases much faster than the y values. Got it? As x increases in the negative direction, the y values increases. As x increases in the negative direction, the y value decreases towards 0. That is the difference between the parabolic graph and the exponential graph. Got it? Let's just start with the practice questions. Let's start with question number 1. Okay, the first one is for part 1. You can make a conjecture about the value of powers with the exponent 0. You can confirm your conjecture using exponent rules. Express 3 by 4 over 3 4 as a single power using the division rule for exponents. So you have to use the division rule for the exponent, and you have to, okay, that would be 3 exponent 4 over 3 exponent 4. Got it? So what we have to do, write as a single power using division rule for exponents. We have to write them down as a single power. So it would be 3 exponent 4, because this, when you have the powers in numerator and denominator, you can write them as 3 4 exponent 4. So it would be then 3 exponent 0. So we can write them as a single power as 3 exponent 0. Got it? Okay. Rewrite the numerator and denominator of the expressions 3 4 over 3 4 in factored form. Simplify where possible what is the value of the expression. Got it? So you can 3 fourth over 3 exponent 4. 3 exponent 4 means that is 3 times 3 times 3. Got it? And 3 times 3 times 3 times 3. Got it? And when we solve them, the answer is 1. Got it? Okay, let's just do the next part. C is based on your results from part A and part B. What you conclude? The simple thing. That means when something has the power 0, that means the answer equal 1. Got it? The conclusion from part A and part 2 is any number exponent 0 equals 1. That is the conclusion from A and B. This is A and B, and that is the conclusion from A and B. Got it? Okay, the next one is repeat. Okay, leave D part. Okay, let's move on to question number 3. Evaluate each power, express your answer in form. So let's just move on to question number 3. Okay, the first one is 2 exponent negative 4. So we can make the exponents positive by rewriting it in the denominator. Got it? It would be 2 exponent negative 4. So you can make the exponent. Okay, let me just read the question, what we have to actually do with this question. Mm, Evaluate each power, express your answer in rational form. Okay, it would be 2 exponent. So we can make the exponent positive by writing it in denominator. It will be 1 over 4. If you shift this to the denominator, then the exponent would be positive. Got it? And 2 times exponent 4 means it is 1 over 2 times 2 times 2 times 2. That would be 2 times 2 is 4 times 4 is 16. It would be 1 over 16. Got it? Okay, the next one is 8 exponent 0. The C part, 8 exponent 0. Any number exponent 0 equals 1. So 8 exponent 0 equals 1. Got it? Okay, the next one is 4 exponent negative 1. Again, you can make power positive by writing it in denominator. So for exponent positive 1, 4 exponent negative 1 is 1 over 4. Got it? Okay, the next one is 7 exponent negative 2. So you have to do the same thing, just rewrite the exponent in the denominator. It would have then positive power. So it would be 1 over 7 square. Got it? And 7 square means you have to do 7 times 7. It would be 1 over 49. Got it? Okay, let's just see in the next one. Okay, move on to question number 4. Evaluate each power as your answer in rational number. So negative 2 exponent negative 5. The first one is negative 2 exponent negative 5. Got it? So that means it is 1 over negative 2 exponent 5. Got it? Because the negative 5 is the exponent of whole thing negative 2. It would be 1 over negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Got it? And it makes negative 1 over 32. Got it? Okay, the next one. Let's just do negative 5 exponent negative 1. Negative 5 exponent negative 1. It would be then 1 over negative 5. Got it? Because either you can write the exponent 1 or you don't write. It would be negative 1 over 5, or either you can say negative 1 over 5. Got it? Okay, then the next one is negative 4 exponent negative 3. Okay, negative 4 exponent negative 3. Got it? So it would be 1 over negative 4 exponent 3. So it would be 1 over negative 4 times negative 4 times negative 4. 4 times 4 is 16, and 16 times 4 is 64. So it is 1 over negative 1 over 64. Got it? Okay, the next one is question number 5. Evaluate each power, express your answer in rational form. So the first one is 1 over 5 square. That means the square is the power of numerator and denominator. Got it? It would be 1 over 2 exponent 2. So of both numerator, and it would be like 1 square over 2 square. Got it? So 1 square is same and 2 square is 4. So it would be 1 over 4. Got it? Then the next one is 2 over 3 exponent negative 3. 2 over 3 exponent -3. You can make the exponent positive by reciprocal the base. Got it? It will be 2 over 3. You can do 3 over 2. Now the exponent is positive. Got it? We are doing the same thing like 2 times exponent 1. We are doing the reciprocal of this thing 1 over 2, and then the power would be positive. So with the same thing I have done for this one 2 over 3 with the reciprocal of the base is 3 over 2, and now the exponent is positive. It would be then 3 exponent 3 and 2 exponent 3. That would be 27 over 8. Got it? Okay, the next one is, let's just start with question number 6. Determine the value of n that makes each statement true. 2n equals 1 over 8. You have to calculate the different values of n. Got it? 2n equals 1 over 8. Okay, 2 exponent n equals 1 over 8. Got it? Just write this in exponent form. It would be 2n equals 1 over 2 exponent 3. Got it? Because 2 times 2 times 2 is 8. You can write it as 2n equals 2 exponent -3. Now the bases are same. That means their exponent are also equal. So x equals n equals -3. Got it? So n equals -3. The next one is 4n equals 64. Got it? So 64 in exponential form, it would be 4n, and that equals, I think, 4 exponent 4. 4 times 4 is 16, and no, 4 exponent 3. Got it? 4 times 4 is 16, and 16 times 3 is 40. 16 times 4 is 48. So when the bases are equal, that means the exponents are also equal. Got it? The next one is n exponent -3 equals 1 over 27. Okay, the next one is n exponent -3 equals 1 over 27. Got it? So let's just make n equals -3 divided by 1 over 3 exponent 3. Got it? So when you move that exponent to the numerator, it would be 3 exponent -3. See, now they have the equal exponents. When the exponents are equal, bases are also equal. That means n equals 3. Got it? Okay, the next one is -3n equals -1 over 9. -3n equals -1 over 9. So it would be 3n equals 1 over 9. Negative signs cancel out each other. It would be 3n equals 1 over 3 square. It would be 3n equals 3 exponent -2. That means n equals -2. Okay, let's just move on to next question. What do you think is greater, 5 exponent -2 or 10 exponent negative? Justify your answer. Okay, 5 exponent -2 and 10 exponent negative 2. 5 exponent negative 2 and 10 exponent negative 2. We need to see which is greater. Got it? So 5 exponent negative 2 is 1 over 25 and it is 1 over 100. Got it? So 1 over 25 equals 0.04 and 1 over equals 0.01. So which is greater? Obviously 0.04 is greater. That means 5 exponent negative 2 is greater than 10 exponent negative 2. Got it? We have to justify your answer. So you can justify by using calculations like got it? Okay, the next one is negative 1. The next one is which what do you think, negative 1 exponent negative 100 or negative 1 exponent negative 101? Which is less? Justify your decision. Okay, negative 1 over negative 100 and negative 1 over negative 101. Got it? So you have to see which is greater. So basically this one is greater. Negative 1 exponent negative 100 is greater. Got it? Because when you have 100 is an even exponent actually. Got it? Negative 100 is an even exponent. So when you solve the exponent, it makes 1. But negative 101 is an odd exponent. When you solve it, makes negative 1. So 1 is greater than negative 1. Got it? That is the justification because 100 is an even number. When you make the when you solve the even one, it would be 1, and when you negative 101 is the odd. When you solve the odd exponent, it would be negative 1. Got it? So 1 is greater than negative 1. So you can do the rest of the questions by yourself later today. So we are working on grade 10 maths. Chapter we're working on from the book, and the lessons we have covered today are quadratic models using factored form. Then we did exploring quadratics and exponential graphs. So please make sure before the next session you have to complete all the test questions, all the practice questions. So if you need more help with any of the practice question, you can join me in the interactive session that will be daily from 9 to 9:45. Got it? So if you need more help with any of the lesson, any topic, you can join me in the interactive session that will daily from 9 to 9:45. Got it? So that's all for today. See you in the next session. Bye everyone.